So let's continue this topic, Introduction to MATLAB, and let's start focusing on data types in MATLAB. Before we get into that topic, I should mention that the data that we represent in any computer programming language is going to be stored in certain data types, and each data type has certain features and operators that work on that data type. And also, like, the number of bytes or bits assigned to each data type is different and might be limited, right? You know that, like, computers are digital devices made out of zeros and ones. So for each data type, we have limited number of bytes available to us. That makes it like different from what we have in real life. So it means that the numbers that we can represent for each data type would have a bound, would be bounded. It would have a maximum and minimum, upper bound or lower bound, right? So that's the limitation that we have because we have finite memory. This set of values that can be represented by MATLAB is also finite, by MATLAB variable is finite. So let's focus on data types that we have available. So MATLAB supports many different data types: integers, doubles, strings, logicals, and so on. A data type is defined by a set of values that can be assigned to the variable of that data type. Also a set of operators that can operate on that specific data type. In MATLAB, when we have an array or a matrix, an array in MATLAB is supposed to be homogeneous. What do we mean by homogeneous? It means that all the elements have to have certain data type, the same data type, right? We can't mix and match. We can mix them up, right? There's a way to do that. We're going to see it later, but usually arrays in MATLAB or matrices in MATLAB, they're supposed to be homogeneous. So, and the data type that is assigned to a variable determines basically for each variable or for each matrix, you need to know the data type, and that data type would determine the lower bound and upper bound of the numbers or characters that you can store in that variable. And for each array, you also need to know number of dimensions, like is it 2D, 3D, 1D, and also the size in each dimension, in addition to the data type that we have to know. So you've already seen the data type of double. One way to figure out what the data type of a variable is using the function class. The function class would give us the data type of any variable that we have. So for example, this is going to be double, this is going to be double, this is going to be a string, this is going to be logical or Boolean, and so on. So this is how you can find the data type of a number. We talked about rand before. You would create a random double between 0 and 1. Random number generation, we also talked about it before. So how can we represent floating numbers in MATLAB? By default, everything it's going to be double. In a typical system, a double variable, a double data type would occupy 8 bytes of memory, which is 64 bits of memory. If you don't need that much, if your numbers are smaller, you can use the single data type, which only has 4 bytes or 32 bits. So also similar to that, we have the same version for integers. In integer, you can have either 1 byte, 2 byte, 4 bytes, or 8 bytes. There are different types of integer that are available to you, as shown in the next slide. You can see that, for example, we have int 8, int 16, int 32, and int 64, right? The numbers represent the number of bits that are available in that data type. or you can use the unsigned version of them, which only stores positive numbers. And you can see that for each data type, the numbers have a minimum and a maximum. For single and double, you can see that because double has basically twice the memory size, you can store the larger number, right? Excuse me. Infinite and not a number are out of the range, right? Like if you have a number that's bigger than this, it would be considered infinite, right? Or smaller than this, it's going to be infinite. Smaller than this or bigger than this. We talked about the class function. It would basically give us the data type of any variable that you have or any matrix that you have. You can also check using isA if a certain variable of a certain matrix of a certain data type, right? So for example, if X is of type double, this would return true. Otherwise, it will return false. You can also find the minimum and maximum of all of these data types using the int max, int mean for integers and real max, real mean for floating point numbers. You can also convert a variable from a certain data type to another data type. So for example, let's say y is 8-bit, you want to make it 32-bit. You can do it like this. Let's say something is unsigned, you want to make it signed. You can do it like this. Okay, or you can single, you want to make it double, you can do it using this function. For each data type, there are certain operations that they come with the data type. So for example, for double and integer, the operators or the functions that come with it is like arithmetic operations or logical operations. You can add, multiply, subtract, divide, find the remainder, or you can compare different variables of type double or integer. You can say like it's greater than or smaller than, which is going to return either true or false. So these are some examples that you can see here. You can try them out yourself. You can basically try to figure out what the answer is first and then try to verify it using MATLAB. We already saw some string examples. So for example, in the input, when we wanted to ask the user to enter a number, we use the string, or like we saw some examples using fprintf and sprintf. So string is basically a combination of characters. You guys are already familiar with the string library in C++. So string is very similar to the C++ version of a string. It's basically a vector of characters. And according to the ASCII code or ASCII table, American Standard Code for Information Interchange, any character is correspondent to a number according to that table, right? The table comes in the next slide. So you can see that, for example, uppercase A is corresponded to number 65, right? Or lowercase a is corresponded to number 97, or 0 is corresponded to number 48, or 32 is a space bar, and so on. So this is like something that you have seen before. Like, so the original table, it was a 7-bit table, so it only have 128 characters, but nowadays using ISO code or Unicode, all the characters, almost all characters of any language in the world, like, should have a corresponding number. This is an example of a function and a loop, and also using fprintf. So I'm using all of them to display all the characters in the ASCII table, all the visible characters. There are some invisible characters or like unprintable characters that we don't include them. So we only go from number 33 to number 126, and we print all the characters using this piece of code. there are also some operators, some functions that would operate on a string data type. So for example, you can find the length of a string. You can go through a string and find like the first element, or like find the elements from 8 to number 13. So for example, for this one, 1, 2, 3, 4, 5, 6, 7, 8, it will start from 8, 9, 10, 11, 12, 13. So it would start from n, it goes all the way to this space. You can compare if two strings are equal, or you can use the strcmp function to do so. You can reverse a string and so on. So I want you to basically first try to analyze this code yourself on a piece of paper, figure out what the answer is supposed to be, and then verify it using MATLAB as an example. So some of the functions that work on a strings, character, you can convert to type character. You can find a string or find a character inside a string. This would return the index number that the character exists in the string, or -1 if it doesn't. You can check if something is character or not character. We saw num2str and str2num briefly before. So you can convert a number to a string or a string to a number. You can make something lowercase or uppercase. You can find the length of a string. You can compare if two strings are equal. You can compare them with ignoring the case sensitivity. You can use sprintf to, or fprintf to excuse me, to display strings and format them as you wish. You can concatenate strings and replace something in a string. So this is like very similar. Many of these functions are very similar to the string library in C++ and the functions that come with that. Excuse me. Again, another example, I want you to analyze these examples yourself first, and then double check them with MATLAB to see if your answer was correct or not. The same for these ones. So, excuse me. So for example, what does it mean to add 2 characters? What is it going to give us, right? It basically means that like we want to add the ASCII version of them, the ASCII correspondent numbers. Or like, how do we determine if something is, if B is bigger than A or B is smaller than C? It basically, we're comparing their ASCII code, not the character itself. The find function basically finds an element inside a matrix, and it would return its index, or it can find a character inside a string and again return its index, or return -1 if it doesn't exist. You can return an occurrence of a certain character or a certain element inside a matrix or inside a string, and you can specify if you want to search from the beginning or from the last, from first or from last. So these are some of the examples of using find. It's a very useful function. That's why I'm putting it here. MATLAB is not, MATLAB is an object-oriented program, but we don't use it that much as an object-oriented program. It's just like, it's mainly used for engineering application, but it has that capability. It has the option to be used as a object-oriented program. Many programmers don't use it that way though. So for example, like it has the capabilities of using something like pointers and structures, but they're not used that much, but it's good to know. That's why like I'm covering it here. So as mentioned earlier, an array or a matrix is supposed to be a homogeneous data structure. It means that all the elements inside that matrix have to have the same data type. But let's say like if if we consider a student and we want to write a program to store its information, each information might have a different data type. So for that, we can use a structure, right? So we can use a structure. That a structure is basically a combination of multiple data types that we put inside one package and we give it a name. In MATLAB, we don't have to have the declaration, and we can just use the structures as we create them, okay? So a structure is basically a heterogeneous data type. And all the different data types that are available are called fields or member variables of that structure. So for example, here, the student dot sn, it means that we have a structure named student. Sn, or student number, is a field of that structure, and we want to assign this number to it. Or we want to assign the GPA to be equal to 2.4 of that student. The student itself is a structure, but the student.sn, should say sn, is basically either integer or double. Okay. The name can be string, the date of birth or year of birth can be integer. You can also have a structure as a field of another structure. So this is what's happening here. Student has a field that itself is a structure, and it's called address, and this address has a field called street. Okay, you might have a student.address.postal code is equal to something else. Some of the functions that can be used for this data type structure is basically get field, returns the value of a field whose name is specified by the string. You can return true or false to figure out if something is a field, if a structure has a certain field or not, if this field exists or not, so it returns true or false. You can return true or false if an argument is of type structure. Is it a structure? This is the same as is char. This is a structure. You can change the order of the fields inside the structure. You can remove a field. You can assign a value to a field whose name is specified in the setField function. You can create a structure with fields whose names are specified inside brackets by strings. So these are some functions that can work on structures. Please go through this example yourself again. Once do it like on paper and then verify it using MATLAB to double check your answers. So in C++, we have a concept, or in many other programs, we have a concept that programming languages, we have this concept that we have a variable that points to another variable. We have something similar in MATLAB called cells, right? Cells are basically similar to matrices, but they're made of variables that basically point to either other data. And those data that are pointed by the cell, they don't have to be homogeneous. They can be of different data types. For example, if I go here, we have a cell with 2 rows and 3 columns. P is equal to cell of 2 and 3. And here, for each of them, we are assigning something different to them. So we are pointing each element of this cell to something, to a different data. So P of 1 and 1, it means this one is pointing to an integer, a 1-byte integer with value -17. Just note that in order to access elements of a cell, you have to use curly bracket instead of round bracket that we did for matrices. For P of 1 and 2 is pointing to infinite because 1 over 0 is infinite. P of 2 and 1 is number pi. P of 2 and 2 is a string awesome. P of 2 and 3 is a matrix, a 3 by 2 matrix. P of 1 and 3, it's a 1 by 2 matrix, which is basically the summation of the columns of the other one, right? So this is what a cell is. It's similar to the concept of pointer that we have in C++. We don't use it that much or at all in this course, but it's good to know that we have this capability. For example, here you have a cell of 5 numbers, 5 elements, that each of them are pointing to different excuse me, to different strings. So this is one way that you can, for example, store a page in a cell, right? So like each sentence is pointed by one element of this cell. Again, there are some cell functions that are available here. I'm gonna skip this because we're not gonna work on them that much. A brief review over the concept of complex numbers. You know that square root of -1 is considered as a imaginary number, right? And we denote that by either I or J. If I write I, this is I, or J, it's going to be the same. Okay. So any complex number would have a real part, which is here, and an imaginary component, right? So here we show that with x and y, x is the real part, y is the imaginary part. Another way to represent a complex number is by its magnitude and its angle. Its magnitude and its angle or phase, right? So we have two ways of representing a complex number, either by real and imaginary, or by its magnitude and angle. In MATLAB, there are functions that would help us to find the real, imaginary, magnitude, and angle. Okay, so these are 4 functions that you can find the real part, imaginary part, magnitude or angle of a complex number in MATLAB. Just be careful that the angle would give you the angle in radian, and you have to convert it to degrees if you want to have them in degrees. Okay, how can we convert x and y to r and theta, or r and theta to x and y? So you know that if this is x and this is y, r is going to be from Pythagoras theorem, it's going to be r squared is going to be x squared plus y squared. Theta is going to be tangent inverse of y over x. X is equal to r cosine of theta, and y is equal to r sine of theta. So you can convert these formats to the what we call polar format, or polar format to the Cartesian format. Both of them are convertible to each other. One theorem that's very famous, and it's very, especially when it comes to complex numbers, it's very applicable. It's the Euler's formula. So you can represent, as we mentioned, you can represent a complex number by its magnitude and its phase. A complex exponential wouldn't, its magnitude, it's going to be square root of cosine squared plus sine squared. So its magnitude is 1. So basically, it says that you can represent any complex number like this. If you know the phase and if you know the magnitude, you can represent it as r e to power j theta, right? If you, again, like find the, according to the Euler's theorem, like if you find the x of this is going to be r cosine of theta, and y of it, it's going to be r sine of theta. So it's exactly the same as what we had before. So according to Euler's formula, we can represent any complex number using a complex exponential function, right? In many cases, we also denote that with just like the magnitude and phase. So we say like, okay, this complex number has the magnitude r and its phase is theta. Complex numbers can also be, as mentioned, can be both expressed in rectangular and polar format. The rectangular format is this one, the polar format is this one. You just like need the magnitude and theta, and for this one, real and imaginary. As I mentioned earlier, you can find the real part of a complex number using MATLAB using the real function, the imaginary part, which is b, using imag function, the magnitude using the absolute function, and the angle using the angle function or angle or phase. But remember that you might need to convert it to degrees. So this shows you an example of what we do with complex numbers. As mentioned, the angle is going to be in radians, so you have to multiply it by 180 over pi if you wanted to have it in degrees, or you can use the built-in functions radian to degree or degree to radian whenever you wish. Okay, so please go through this example and figure out if there are any confusion, any problems, if you understand everything. Now, let's look at this one, and I want you to guess what this is. What is this supposed to do? So you know that any function, if you want to find the roots of it, it means that like for what value of x, f of x becomes 0. Now, do we have a function here? What is this? Okay. So if you remember, I mentioned earlier that any polynomial in MATLAB can be represented by its coefficients, the coefficients of each term. So this is basically 1 plus no x squared, no x cubed, and there is x4. So this is basically, if I run this, it would give me the roots of x4 plus 1 equal to 0, right? Which is going to be these complex numbers. So I'll try to use these opportunities to show you different functions that are available that might be helpful in your other courses. If you add two complex numbers, their real parts are going to be added and their imaginary parts are going to be added. You can do the same thing in polar coordinate system, but it's going to be a little bit challenging. You have to convert it back to x and y's and then add x's and y's. So it's easier to do summation and subtraction in rectangular coordinate system. However, for multiplication and division, it's going to be much easier to do it in the polar coordinate system. If you multiply two complex numbers, their magnitude is going to be multiplied by each other, and their phases are going to be added to each other. For the division, their magnitude is going to be divided by each other, and their phases are going to get what? Subtracted from each other. Yes. Okay. So we already covered that. So what is a conjugate of a complex number? You guys have seen this before, and in MATLAB, to find the conjugate of a complex number, you can use the conj function. In addition to the four functions that I already mentioned, this is another one for complex numbers. The conjugate of complex number is basically a complex number with the same magnitude but the reverse phase. Or you can think of it as a complex number with the same real part but the negated imaginary part. So that when you add these two together, the imaginary parts, they would cancel each other and the real part gets doubled. So as you see here, if I add these two, which are basically a vector, if I add them together, their imaginary part is going to get canceled because one is facing this way, one is facing this way, and the real part gets doubled because both of them have the same real part. Why is complex numbers important? In many applications in engineering, we represent sinusoidal waveforms or vectors similar to a complex number. We represent them with a magnitude and a phase. Okay. According to the Euler's formula, you saw that cosine and sine can be converted into a complex exponential. So that's the duality between sine and cosine and the complex numbers. So in many engineering application, for example, we represent a sinusoidal wave with its magnitude and how much phase shift it has, which is very similar to the way, exactly similar to the way that we represent complex numbers. So we can represent sinusoidal waveforms using complex numbers. As an example, here we have 3 AC voltage sources, right, which they have different magnitude, but they have the same phase. They have different magnitude, but they have the same frequency, but they also have different phases. So we represented them using the magnitude and phase, and we want to add them up. How do we add them up? Right? How do you add complex numbers? Right? So for the real part, this is going to be 12 cosine of negative 42. For this one, it's going to be 8 cosine of 69. And for this one, it's going to be 10 cosine of 90, which is 0. So you add them up, that's going to be the real part. For imaginary part, it's going to be the sine. 12 times sine of negative 42 plus 8 times sine of 69, 69 plus 10 times sine of 90 degrees, which is 1, right? So you can find the real part and imaginary part, and you can convert it back to the polar coordinate system to find the equivalent source equal to the summation of these 3 using complex numbers. In MATLAB, as I mentioned, like if you want to find the real part or imaginary part or absolute value or the phase and conjugate, there are functions available that you can use. A good point to stop. Thank you so much. I'll see you guys later.